For this problem, 9 out of 10 kids can't solve it. Let's take a look at the question. This problem asks us to fill in the blanks with appropriate numbers so that the sum of the three numbers in every row, every column, and both diagonals is the same. Many students try one number after another but still can't find the correct answer. Actually, for problems like this, it's very simple once we find the breakthrough point. So where is the breakthrough? It's called finding the common number. What is a common number? For example, this position here, I call it a common number because it's part of both this row and this column. We know that the sum of the three numbers in this row and in this column should be equal, right? So if I take it out, doesn't that mean the sum of these two and the sum of those two are also equal? If these two add up to 48, then those two should also add up to 48, right? So the number in this position should be 48 minus 30, which is 18. There, we filled in the first position. All right, so which other positions are also common numbers? For example, this particular position, I'd say that it's also a relatively common number, mainly because it's both on this diagonal and also in this row. We know that the sum of the three numbers in each row, each column, and each diagonal is the same. So the sum of these three numbers is equal to the sum of those three numbers. Since it's here and here, if I take it out directly, doesn't that mean the sum of these two equals the sum of those two? So what do these two add up to? That's 45. So the sum of these two is 45. What about this one? 45 minus 30, so isn't this position 15? Actually, at this point, the sum we're trying to find, the sum of the three numbers in each row, each column, and each diagonal, we call that the magic sum. Up to here, we can already find the magic sum. Do you know why? Look, isn't this a diagonal? Aren't these three numbers already here? It should be 15 plus 18 plus 21. What's that equal to? 15 plus 18 is 33. 33 plus 21. Oh, the magic sum is 54. All right, now that we know this condition, I can figure out all the remaining positions. For example, let's look at this column. Shouldn't the number in this position be 54 minus 27, then minus 15? That should be 12, right? Now, for this row, shouldn't it be 54 minus 12, then minus 18? What should the number in this position be? Isn't it 24? All right, for this position, 54 minus 27, then minus 21, shouldn't this position be 6? Now, for the number in this position, isn't it just 54 minus 21, then minus 24? That should give us 9. All right, with that, we've finished this problem. I suggest everyone give this a like and save it to watch a few more times. Otherwise, if you want to use such a useful method again, you might not be able to find it.